The next problem also deals with rational equations. Look at the directions. We have to set up an equation to solve. If you don't do this part, you will receive no credit on the final examination, even if you somehow guess at the right answer. So how do I set up an equation to solve? The sum of a number and its reciprocal is 25/12. So if I let x be the number, what is its reciprocal? Well, what is the reciprocal? That's the reciprocal. What are we going to do with those two things? We're going to add them together. Is equal. So that's the equation that we're looking for. Now how do we solve? Well, just like on problem number 8, I find the LCD, which in this case is just 12x, and I'm going to multiply every term by 12x to get rid of my fractions. Right, so this one, nothing reduces, so I have 12x squared. Here the x's go away, so I have 12. Here I have 25x. And just like the last problem, I need to set it equal to 0, and I'm going to put that in the middle so it's in standard form. And again, we have that trinomial. So whatever method, we should end up, I believe, with those numbers. Again, I'm checking to make sure I get 25 negative in the middle. And I do. So I set both factors equal to 0 and solve. Sure enough, I get two answers, but it says find the number. Well, x was the number, and I actually have two possibilities. That's okay. And if you look at those two numbers, they are reciprocals of one another. And if you add 3/4 plus 4/3, find a common denominator, you're going to get 25/12. So again, even though it says the number, two solutions. So the next grouping of problems deals with radicals. Now it says assume all variables represent positive numbers just because they don't want to go into the imaginary number part. Does it have any effect on the way you work the problem? No. Alright, so how do we simplify a cube root? Again, different teachers teach this differently, but I'm going to look at 16. What I'm going to do is I'm going to factor out 16 to the prime factors. Maybe you've been taught that it's just 8 times 2. Either way is okay. Now you can write out 9 x's, but I'm not. I'm just going to leave it like that for just a minute. So if I'm looking for the cube root, I'm looking for 3 of a kind. So I can take out a 2 and leave a 2. But what about that? Well, again, you could write out 9 x's. In fact, oh, why not? I'll just do this. Right? I think that's 9 x's. If I'm looking for a group of 3, well, I have 3 groups. So I'd have an x times an x times an x, which would be x cubed. You also can divide the exponent by the root and get 3. So if I have y cubed, the cube root of y cubed is just y. Again, different teachers explain that differently, but we'd all get the same answer. So number 11, we're looking for a square root. So again, I'm going to break down 50 into 5 times 5 times 2, or again, maybe you were taught to look at it as 25 times 2, all the same. Then I have x to the 7th and y to the 9th. So since it's a square root, looking for a pair, so I have that. Again, x to the 7th. You can do this. That's the slow way, but it gets the job done. And see how many pairs you have. So I have x cubed, and it would leave an x. But again, you can take the exponent of 7 and divide it by 2. So 2 goes into 7 3 times with 1 left over. So I have x cubed with 1 left over. So if my exponent is 9, 2 goes into 9 4 times. I have y to the 4th, but I have 1 left over. You could also write it as a different exponents. A lot of different ways to get there, but that's one way. Number 12, combine the following expressions. Well, how do I do that? Well, first of all, they have to be the same radical to even think about combining. And if you look, they're all three different. I mean, that's different, then that different, different, different. But what we can do is simplify the radical first. So 18. Again, 18 is 3 times 3 times 2, or you were taught 9 times 2. This one is x times y. 12 is 2 times 2 times 3. They're all square roots, so you're looking for pairs. So that's going to come out. That's going to come out. That's going to come out. And that's going to come out. So let's see what's left. We have 3x squared and be left with 2y. This x comes out, and that would be make that x squared, and I'd left 2y. The 2 comes out with the 4. I multiply that together, and I'm left with 3x. Then I have a y, and I'm left with 3x. So again, I have to be able to have the same radical. Well, those two are the same, and those two are the same. All right, so can I combine those? Well, are the coefficients like terms? Yes, they are. So 3x squared minus 1x squared is x squared, and you keep the radical. I can combine those because the outside parts are also like terms. 8y minus 1y is 7y, and you keep the radical. And to be honest, this one's probably a little bit harder than the one on the exam, but if you can understand this one, the exam will be a piece of cake. Now let's look at rationalizing the denominator. Look at these two problems. Same directions, but they look different, and it's because you do different things. So here I want to look at the square root of 13. Rationalize means get rid of the square root in the denominator. Multiply by something that will make that happen. So if you multiply by the square root of 13 on top and bottom, that is the square root of 13 times 13, which just gives you 13. On top, I can't multiply those per se. I can just kind of stick them together with implied multiplication. And that's it. You can't reduce it. That's it. Now number 14, a little differently, because you have two terms. I can't just multiply by an x or a y. That's not going to work. So we have to multiply by what's called the conjugate. So you have the square root of x plus the square root of y. So it's the same denominator, but with a different sign. Right? I'm not going to go over why this works. You should have already had that lesson, but when you multiply this times this, you're going to get x. Multiply those two minus y, and when you do the insides, those would add to 0. So I can leave my answer like this, but I'm going to go ahead and distribute. The square root of x times the square root of x is x, and this is the square root of xy. Okay, so now we have some fractional exponents. Evaluate. Well, you have to know on a fractional exponent that the bottom number is the root and the top number is the power. You can do the power then the root, or you can do the root and then the power. I choose to do the root first because they're usually get you smaller numbers that way. So I want to take the cube root of 8 and then square it. So you should know the cube root of 8 is 2 squared. That's 4. But this one has a negative. So before I can do anything else, I have to make it a positive exponent. So I take the reciprocal of the base and change the sign of the exponent. Don't flip the exponent, flip the base. So again, this says to take the square root and then cube it. Again, I could cube it, but those numbers are big. I'm going to try for the square root first. So the square root of 4 is 2. The square root of 49 is 7. And now I have to raise that to the third power. So that's 8. And yes, 7 times 7 times 7, a little bit big. Not impossible, but I believe that's 343. So remember, root, power. Negative, flip that base. What about this one? Simplify. Well, it's really, we're just multiplying those together. So let's multiply 5 times 6 is 30. And then I have to multiply x to the 2/3 times x to the 5/2. Well, what's my rule? If the bases are the same being multiplied, then I have to add my exponents. So I have to add 2/3 plus 5/2. Back to 5th grade, find a common denominator, which is 6. So I multiply that by 2. I multiply this by 3. And I get 19/6. So what is that answer? The 30, then x, keep the base, and add those exponents. And you're done.